So this video is just a brief review of the exponent rules that you guys investigated and then we summarized last year in grade 7. They can be sometimes confusing because it's hard to remember what each one is. So remember, when you're doing these, try to think about the meaning behind them as opposed to just memorizing a rule. So the first rule is called the multiplication rule. And last year we did investigations where we looked at why that rule was what it is. So here we're just going to actually summarize what the rule is. So the rule says to multiply powers with the same base, you blank the exponents. So if you think back to last year, when we multiplied, we ended up adding the exponents. So we'll fill that in the blank. So an example of this, so this here, x to the m times x to the n equals x to the m plus n. It's just the fancy mathematical form of saying what the rule says above. And an example at the bottom here, 3 to the 7 times 3 to the 4 is equal to 3 to the 11. The really important thing to remember with that rule is that you keep the base. So you add the exponents, but you keep the base. Now let's look at the next rule, the division rule. So when you're dividing powers with the same base, you subtract the exponents. And again, keep the base. So again, this here is just a fancy way of saying that using mathematical language. And the example below is 5 to the 6 divided by 5 to the 2. So 6 minus 2 is 4. So that will just be 5 to the 4. Remember, just as an aside, if you ever got a question that would say 4 to the 4 divided by 4, remember that 4 by itself means 4 to the 1. So if you were to evaluate that, you would do 4 minus 1 and get 4 to the 3. So just be careful of questions like that. And the final rule is called power of a power rule. And that occurs when you're raising a power to another power. And in this case, you multiply the exponents. So again, it's written in mathematical language at the bottom. And the example, 4 to the 3 raised to the exponent of 2 will become 4 to the 6 because 3 times 2 is equal to 6. Now, depending on what the question asks you to do, you might just be leaving your answer in exponential form like we did for these. Sometimes you'll be asked to evaluate. If you're asked to evaluate, that means get the answer. So now if we look at an activity with this, we have to sort of match up the correct solutions. So 3 to the 7 times 3 to the 6, we're multiplying, and the powers are the same base, so we're going to add the exponents. And 7 plus 6 is 13. So the correct answer to that one is 3 to the 13. The next one is a tricky one. There is no exponent rule for adding. So I sometimes call this the Nike rule. And the reason why I call it the Nike rule is the slogan of Nike is just do it. And so in this situation, what you really have to do is follow bedness and figure out what each part is individually. So figure out that 3 to the 7 is equal to 2,187, and that 3 to the 6 is equal to 729, and then add those together, and you'll get your answer of 2,916. So that particular one, be very careful. There is no rule for adding to exponents. The next one is an example of the power to a power rule. So with the power to a power rule, you multiply the exponents. So that will be 7 times 6 is 42. So that will be 3 to the exponent of 42. This next one is an example of the division rule. The bases are the same. When the bases are the same and we're dividing, you subtract the exponents. So 9 minus 3 is 6. Be really careful because common mistake would be to get it mixed up and think dividing, I'm going to divide the exponents. So just be really careful with that. Again, the last one is an example of the Nike rule, although don't call it the Nike rule to anybody but me because that's not the real rule. It's just a way that I used to remember that you just do it. You have to follow bedness and just figure out the answer. So in this case, 3 to the exponent of 9 is 19,683. And 3 to the exponent of 3 is 27. And then you figure out that that equals 19,656. So when you're using the exponent rules, really make sure you understand what the rules are asking you to do and understand when they apply and when they don't apply. If the bases are different, or if you're adding or subtracting, there is no rule for that. And so you would have to just do it. You'd have to follow the rules of BEDMAS, show all your work, and answer the question. You can only use the rules when the bases are the same, and you're either multiplying, dividing, or raising a power to a power.